Hello students, we are going to start with the chapter 4, that is chemicals and chemical changes. In this chapter we are going to learn about the chemical substances, chemical symbols, chemical formulas, chemical equation, chemical and physical changes. Before going to that, let us see the following images and name the substance. Coins. Coins are made up of metal. Foil paper, they are made up of a metal like aluminium foil. Pencil, it is made up of lead, that is graphite. Spoon, spoon is made up of metal, that is it is an alloy, that is steel. Vase, it can be made up of brass or bronze. So we see so many metals in our daily life, and we see many changes occurring around us in our daily life, like change in climate, soaring of milk, burning of paper. These are some changes that you come under. Rusting of iron. The changes can be different types, that is desirable change or undesirable change, slow change or fast change, temporary change or permanent changes, reversible or irreversible changes, physical change or chemical change. All of these changes involves one or more substances. Every substance has a unique composition. So in order to understand this, let us learn about the composition of these substances. First, chemical substance. See, all substances are made up of matter. Anything you are using, you are having pen in your hand, you are having pencil in your hand, anything, the air you breathe, anything, it is made up of matter. Then what is matter? The question arises, what is matter? Matter is anything that has mass or weight and occupies space. Suppose if you are having a pencil in your hand, it is having a weight, that it is having a mass, and it is occupying a space. So this is called as matter. The chemical substances are made up of atoms and molecules. So the chemical substance, if we are saying that pencil is a matter, the air you are breathing is a matter, then they may be made up of something. They are made up of atoms and molecules. So atom is the smallest unit of matter. Okay, atom is, the matter is made up of atom, so it is the smallest unit. It has been derived from a Greek word atoms, means indivisible, which cannot be divided. Atoms can also be defined as smallest particle of an element or a compound that exhibits all the property of that substance and may or may not exist independently. Again, I am repeating, atom is the smallest particle. We have told you that matter is made up of the smallest particle called as atom. So atom is the smallest particle of element or a compound. Okay, it is the smallest particle of element or a compound that exhibits all the property of a substance. This atom shows all the properties of the substance, and it may exist independently or it may not exist independently. Then what is molecule? When two or more atoms combine together, they form a molecule. What is molecule? When two or more atoms combine together, they form molecule. Okay. Substance can be generally, there can be two types of substance can be pure substance or impure substance. Pure substance consists of only one kind of atom or a molecule. Pure substances are made up of only one kind of atom or a molecule. Whereas impure substances, which are called as mixtures, they are made up of different types of atoms or molecules. Okay. Element and a compound is a pure substance. Element or a compound is a pure substance. Now, what is element, what is compound, and what is mixture? Okay, we'll go with the definition of element. Element that is made up of only one type of atoms and cannot be broken down into simpler substance. See, elements, they are made up of only one type of atoms and you cannot break this atom into more simpler substance either by physically or chemically. They are called as elements. Whereas compounds, the substance in which two or more elements combine together in a definite proportion, they are called as compounds. Okay, if you combine two or more elements, they form a compound, but these elements should be combined in a fixed proportion. So, what are elements? Elements consist of only one type of atom. Each element has its own properties. Atoms of the elements have all the properties similar to that of specific element. Okay, now elements can be classified into two types, that is metals and non-metals. Like element like oxygen, like iron, copper, gold, silver, mercury, oxygen, sulfur, they come under elements. Then what are compounds? The compounds are nothing but we have told you that when two or more elements combine together, they form compounds. Suppose if I combine hydrogen and oxygen, they form water. Carbon and oxygen, carbon dioxide or carbon monoxide. Sodium and chlorine, sodium chloride, they are compounds. Okay. Next, when two elements combine to form a compound, they loses their characteristic property and hence the new compound will form of different properties. See, if I take hydrogen atom and oxygen atom, I made them to combine to form water. The properties of hydrogen and properties of oxygen are different. When they combine, you will get the water with different properties but not with the same properties of hydrogen and oxygen. Okay, now example I have told of compound, that H2O, CO2, NaCl, these are the examples of compound. Next, mixtures. When you mix two or more substance physically in any proportion, they call mixtures. Suppose you take sugar, you take water, mix them, that is mixture. You take sugar, you take salt and water, mix them, that is mixture. Okay, this is called as mixture. So substance in which two or more substances are mixed together physically with any with different proportions, they are called as mixtures. Example, sugar solution, salt solution. Air is a mixture of gases. Okay, air contains different kind of gases, so it is a mixture of gases. Now chemical symbols. What are chemical symbols? See, till now there are 118 elements. In 118 elements, 94 elements, they are naturally found on the earth and remaining are man-made elements. Now, how to represent these elements? The representation of an element using the short form or abbreviation is known as chemical symbol. What is chemical symbol? Chemical symbol is the representation of the elements using the short form or abbreviations. All the names and the symbols of elements are proposed by IUPAC. This is important. What is IUPAC? International Union of Pure and Applied Chemistry. You have to learn this definition, abbreviation. That what is IUPAC? International Union of Pure and Applied Chemistry. They give the approval what the symbols and what the names of the element should be given. So they decide. In earlier times, a pictorial representation of the element was used. Later, the elements of were changed, named after the place where the first they were found. See, first it was the scientist who called as Dalton who discovered the symbols of the elements, but his symbols was pictorial presentation, means it was in the form of pictures, and it was too tough to identify means to remember the pictures of the each element. So then Berzelius was the one scientist who suggested to put the names, to put the letters for the in the letters to be used in the form of symbols. Okay, and what he has done, he has used either the name, the first letter of that name of the element, or he has used the letter from where it has been found. Like copper, the Latin word was cuprium, so its symbol is Cu. Now, in the modern representation of the elements, the letters representing the names of the elements are used for the symbols. For some elements, the first letter of the name is used as the symbol, which is always written in the capital letter. The first letter is always the capital letter followed by another letter. Okay, so suppose an element with the name with the name carbon. So we use the symbol as C. Another element with the name copper, Copper. The word, it is starting with the same letter C. So we use the symbol of the copper as Cu. It has been followed by another letter. Okay, if two or more elements have their English name starting with the same letter, then two letters of the symbol is used. To represent such element, the first letter of the name is used as the first letter of the symbol, which is written in the capital letter. So first letter should always be written in the capital letter. Then the next non-repeating letter of the name is used as the second letter. So next, if they have the same letter, then you have to use another letter for the symbol, which is a small letter. For example, C for carbon, Ca for calcium, Cd for cadmium, Cl for chlorine, and Co for the cobalt. See, same, they are starting with the same letter. So we started using another letter for this. The first letter should be the capital letter and the second letter should be a small letter. Okay, see, some elements, the symbols of the are derived from the Latin names. For example, gold is Au. The symbol of gold is Au. It has come from the Latin word arum. Okay, see, a table is given in which the symbols of some elements are given. You have to learn this name of the elements with the symbols. Okay, next, atomicity. What is atomicity? The number of atoms that make up a molecule of an element. The number of atoms present in a molecule of an element is called as atomicity. Like H2O, how many atoms are present? Here 2 hydrogen and 1 oxygen atom is present. So its atomicity is 3. CO2, 1 carbon and 2 oxygen atoms. So the atomicity is 3. Number of atoms present in a molecule. So the atomicity of the element is written on the right hand side of the symbol as subscript based on the number of atoms present. Elements can be classified as monoatomic, diatomic, triatomic and tetraatomic. So they can be classified as monoatomic, diatomic and tetraatomic. See table is given. Helium means it comes under monoatomic. So atomicity is 1. Monoatomic means 1 atom. Chlorine is diatomic, means 2 atomicity, 2 atoms. Okay, this table you have to learn, this table also, elements with the atomicity. Next, chemical formula. What is chemical formula? The symbolic representation of the composition of a chemical compound. The symbolic representation means by symbol we are representing a chemical compound, that is called as chemical formula. Like water, H2O, carbon dioxide, CO2. You have learned this chemical formulas. This is a short form to represent the chemical compound. The chemical formula shows different element present in a molecule of a compound. The number of atoms of each combining or the constituent elements in a compound. Okay. For example, sodium chloride, that is the common salt, the salt which you use, your mama use in your kitchen, that is sodium chloride. We call it as sodium chloride, and the formula is NaCl. You have to learn the formulas. Next, see, formulas of some compound is given like water, ammonia, sodium chloride, potassium chloride, carbon dioxide, magnesium chloride, hydrogen sulfide, methane, hydrochloric acid. You have to learn this table. Otherwise, it will be tough. So, start learning. Next, what is valency? Valency is nothing but the combining capacity of an atom of a element with the atoms or other element is called as valency. Again, I am repeating the definition. What is valency? Valency is the combining capacity of the atom of a element with the atoms of other element is called as valency. The valency of element is always a whole number. It cannot be fractions, it cannot be in the points. So it is always a whole number. We can determine the valency of the element by looking the chemical formula of the compound. We can find out the valency of the element by looking the chemical formula of the compound. For example, MgCl2. That is magnesium chloride. What is MgCl2? Magnesium chloride. So here magnesium, one atom of magnesium combines with the two atoms of chlorine, MgCl2. Here magnesium is 1, chlorine is 2. So magnesium, the valency of magnesium is 2 and that of chlorine is 1. Opposite. Whenever you write a chemical formula, whatever the number you are writing at the bottom, like MgCl2, magnesium's valency will be the number at the bottom of the chlorine, whereas the chlorine valency will be the number at the bottom of the magnesium. So magnesium is having only one atom, so chlorine valency is 1. Magnesium is having, chlorine is having 2 atoms, magnesium valency is 2. If it is H2O, hydrogen 2 atoms, so oxygen valency is 2, but oxygen is 1 atom, so hydrogen valency is 1. Opposite, again like NH3, one nitrogen means this one nitrogen, the one atom is of hydrogen, so hydrogen valency is 1. 3 hydrogens are there, the number 3 is the valency of nitrogen, so opposite valency. Okay, see, valency of some elements are given in the table. Sodium 1, potassium 1, silver 1, zinc 2, magnesium 2, calcium 2, aluminium 3, hydrogen 1, chlorine 1, carbon 4, oxygen 2 and iodine 1. This valency table also you have to learn. So try to learn this valency table. Next, how to write the chemical formula. See, chemical formula, writing of chemical formula is easy if you learn the valency of the above table. First, write the symbols of the element that forms a compound. If I am telling you to write the formula of magnesium chloride, first write the symbol of magnesium, that is Mg, and chlorine Cl. Write their valency on the top of their symbol as superscript. If you want, you can write the valency. See, magnesium valency is 2. So write Mg on the top 2. And chlorine valency Cl, that is 1, at the top of chlorine 1. Now do crisscross. Write the valency at the top of their subscript. If the valency are identical, cancel the valency. If the valencies are same, like 2, 2, then cancel the valencies. But if the valencies are different, you cannot cancel. Okay, if the valencies are different, then interchange the valencies with respect to the symbols for making the by making the arrow. Make the arrow. See the diagram. The arrow is made. That is, the chlorine is having 1 atom. We have written 1 on the top. Magnesium 2. Valency of magnesium is 2. Now do crosswise. Now by making this arrows, write their subscript. Like magnesium 2, it will go, the number will go to chlorine, so Cl2. Chlorine valency is 1, this number will go to magnesium. Then write the formula MgCl2. Okay. Similarly, see, magnesium and oxygen. Magnesium valency is 2, right at the top. Oxygen valency is 2, right at the top. Now write, by crisscross method, write the numbers at the bottom. Oxygen will get the 2 number and magnesium will getting the 2 number. So they are having the same valencies. So cut that. So formula is MgO. See, next, give one word of the following. The smallest unit of matter is atom. The substance formed when 2 or more atoms are chemically bound together is called as molecule. You can also call it as compounds or molecules. The substance that contains only one type of atom is elements. The representation of element using short form or abbreviation of this of its name is chemical symbol. The number of atoms that make up a molecule of element is atomicity. Next, chemical equation. What is chemical equation? Now, chemical equation, if any chemical change is occurring, that is, any chemical change is occurring in which a new substance is formed, that is called a chemical reaction. A chemical change resulting in the formation of new substance is called as chemical reaction. Whenever you see, if there is a chemical change taking place, it means any new substance has been formed, then it means that a chemical reaction has taken place. For example, keep the milk, leave the milk for 24 hours. After that, what you will see, the milk has been spoiled. That means souring of the milk. It means that the milk has been changed into a chemical substance. That means a chemical reaction has taken place. Take the paper, burn the paper. After burning, what you will get? You will get ash. It means that the properties of the paper are completely different from the properties of ash. So a chemical change has been taking place. This means a chemical reaction has taken place. Now, what is chemical equation? Chemical equation is representation of the chemical reaction using the symbols and formulas of the element or compound that is involved in a reaction is called as chemical equation. Means representation of chemical reaction. The reaction which has been taking place, we are going to represent either through the symbols and formulas of the elements or compounds. That is chemical equation. The chemical equation can also expressed in words by writing the names of the elements or compounds, or this kind of equation is called as word equation. If you're writing the names in the chemical equation, that is called as word equation, and if you're writing the chemical formula, that is symbolic representation. So writing a chemical equation, for writing we are having reactants and products. Then what is reactant? A chemical substance that participate in the chemical reaction. The chemical substance, that is, if you're taking a paper on burning in the presence of oxygen, okay, so that is reactant. The new substance which is formed is called as product. Okay, the chemical substance that participate in the chemical reaction is known as reactant, and the new substance that is formed in the chemical reaction is called as product. Now, how to write a chemical equation? So, to write a chemical equation, the reactants are written on the left hand side, whereas the products are written on the right hand side. Okay, reactants are always written at the left hand side, and the products are always written on the right hand side. Okay, if there is more than one product, then we are going to write the two products and indicating them with the plus charge. If there are more than two reactant, you have to show the reactant by adding them. The change of reactant to product is indicated by an arrow. The head of the arrow points towards the product. See, head of the arrow. See a chemical reaction on the next page. See, magnesium plus oxygen gives rise to magnesium. We are using two reactants, so we are adding them. Product has formed as magnesium oxide. We are showing with an arrow. Okay, this magnesium plus oxygen, this first reaction is a word equation, and the next reaction is the symbolic representation of the reaction. Okay, this is a chemical equation. The first word equation has been written. Magnesium plus oxygen gives rise to magnesium oxide. Then we write the chemical equation by using the symbols and formulas. Now, the next step is how to balance the chemical equation. Balancing of the chemical equation. This is an important. Suppose if we take a reaction that is Mg plus O2 gives rise to MgO. Now, how to balance a chemical reaction? So, for balancing a chemical equation, you have to make a table. Write the element, number of atoms in the reactant, that is on the left hand side, and number of atoms in the product on the right hand side. Element are magnesium and oxygen. Number of atoms in the reactant is 1. Oxygen is 2. In the product, magnesium is 1 and oxygen is 1. Now you have to balance this number. If you balance oxygen, automatically the magnesium will also get balanced. So first try to balance the atoms with the high element with the more number of atoms. Like oxygen, it contains 2 atoms in left hand side. So what we are going to do, we are going to multiply 2 on the product side. 1 into 2 becomes 2. Oxygen is balanced. Now oxygen is balanced. Write 2 on the where MgO is returned. Now magnesium atom becomes 2. Now you have to multiply the magnesium also with the 2. Okay? Because if you are multiplying oxygen with the 2, then magnesium atom will also become 2. In the product side, 2 magnesium atoms are there and 2 oxygen atoms are there. But in the reactant side, only 1 magnesium atom and 2 oxygen atoms are there. Now try to balance. Now what we'll do, we will balance the magnesium also by multiplying it with the 2. So 2 magnesium plus O2 gives rise to 2 MgO. Okay. So in this way you have to balance a chemical equation. See, write a balanced chemical equation for the given chemical reaction. Try to balance this chemical equation. Like Hg plus O2 gives rise to HgO. How many atoms of oxygen are here? 2. So what you will do, first you will balance the product. You will write 2 HgO. When you will write 2 HgO, then 2 Hg atoms of mercury will become 2. So you have to multiply 2 in the reactant also. Similarly, aluminium Al plus Cl2 gives rise to AlCl3. See, 3 chlorine atom is there. Now think of a number which comes in the table of 3 and 2. That is 3 2s are 6. What you will do? You will multiply. If 2 chlorine atoms are there, you will multiply with the 3. And if 3 chlorine atom is there, you will multiply with the 2. So it will become 2AlCl3. So again multiply aluminium with the 2 in the reactant side. Zinc plus HCl gives rise to ZnCl2 plus H2. 2 chlorine atoms, 2 hydrogens. Multiply it with the 2 HCl. It will get balance. K2O gives rise to K plus O2, 2 oxygen. First balance oxygen. 2O. It means 4 atoms of K becomes. Then multiply K with the 4. Similarly, sodium plus O2 gives rise to Na2O. Try to balance oxygen in the products. That is multiplying 2 with the 2 to Na2O. Then what will become 4 sodium atoms? Multiply the 4 sodium in the reactant site. Okay, in this way you try to balance these chemical reactions. I am going to end the session till here. Thank you.